If a table shows a linear pattern, then we can write a linear function from it. For example, if we see that h of x going from 13 to 10 to 7 to 4, it's consistently subtracting 3 each time. So we know that that has a pattern. And we look at the x values, each time is consistently adding 1. So we say that the rate of change then is going to be the y value. So here h of x is the same as y. So y value divided by x value, that's going to be our rate of change. So negative 3 divided by positive 1, that's negative 3. And that's going to be our rate of change here. Now to find the initial value from a table, we just need to find the y value when x equals 0. Okay, so here we see that in this step, x equals 0, and accordingly the y value is 10. So that is going to be our initial value. With these two, we can put together a linear function, and we call that h of x, because that's what's given, the name, equals mx plus b, and mx would be the rate of change times x, plus b would be the initial value. So on another example, we see a different table. It goes sideways, but it's the same procedure. So we first want to find the rate of change. So notice the k of x values is going by adding 6 each time consistently. Now, before we write down the rate of change, we want to see how x is affecting it. So if you look at the x values, it's going by 3 each time. Okay, so if we just put plus 6 as our rate of change, we're ignoring the fact that it's skipping a few steps each time because it skips 3 steps to go to the next one. So that is not the rate of change. The rate of change should be a unit rate. So it's like per one step. So what it means is we'll have to do our y value, which is k here, divided by x. So how many times x is changing? So we'll do here 6 divided by 3 because it's changing by 3 each time. So y is changing by 6 each time, x is changing by 3 each time. So if we simplify this fraction, we're going to get 2. And 2, positive 2, that's our rate of change. Now to find the initial value, we need to find when x equals 0. But the table didn't give us that, so we need to find it. We need to go backwards until the table tells us when x equals 0, what the y value is. If we go backwards just one time here, we're subtracting 3, because if you go forward, it's adding 3 steps, so you go backwards, you subtract 3 steps. And the y value will subtract 6 accordingly, and that's going to give us 27. And the x is 3. But that's not the initial value yet because x is not 0 yet. So we need to go backwards one more time. And that's going to give us 0 because 3 minus 3 is going to get us 0. And we can stop here. We just need to make sure that the y value is also going back one more time. So 27 subtract 6 is going to be 21. So this 21 here is going to be our initial value. And to put together a function, we'll say that the function is k of x equals the rate of change 2 times x, the variable, and then add the initial value.